The console consists of a CRT display, a RAND tablet, and a single hardware button. The display has a line generator, character generator, short vector generator, and 4 levels of brightness control. The tablet work area is the brown 10 1/4 by 10 1/4 horizontal surface. The stylus has a micro switch in the tip, which when closed allows the transmission of stylus XY position data to the computer. The hardware button near the green light invokes the system's sign-on display. Note that the stylus is handled much as a pencil or pen might be. The virtual stylus position is represented on the display by the point of light. The point follows the operator's hand motions as though attached directly to the stylus. When the pen is pressed lightly against the tablet, the pen switch closes and the system responds by providing an ink track on the display. When the pen is lifted, the track disappears. The operator's hand moves freely in 2 dimensions. Figures of random size and position may be drawn with exactly the motions used in drawing them with pencil on paper. The tight feedback and natural hand motions enhance the feeling of drawing on the display. When a symbol is drawn in an appropriate area, the system replaces the ink track by the corresponding stylized symbol. A group of virtual buttons is represented at the top of the display by the labeled areas. The system function is obtained by pushing on the corresponding area. We are about to press on the button marked File Editor. The File Editor controls graphic files. For instance, a file name may be dragged from one area to another. This sequence holds the name of a file temporarily while the file is destroyed. Then a copy of a second file is made and given the same name as the destroyed file. We may then access the copy. This scene illustrates some of the flowchart symbolism: a process box, a decision element, and a remote connector, and a flow arrow from the decision to the connector. Connectors are labeled with the convention that there may be many instances of the connector with control flowing into them, but exactly one instance with control issuing from it. There are several kinds of process boxes, for instance one with its corner cut off. This is a labeled box indicating that it represents one instance of the named subroutine. This is also an instance of a labeled subroutine, but of a restricted type. The unlabeled box indicates that it represents an inline function. We may press on the box to discover its details. This display represents those parameters which the routine expects to be supplied to it, and some comments about the form of those parameters. The operator translates the original symbols into those he finds more convenient. For example, FOX is translated into VAR3. The checks to the left define the data type. To pass through the interface display to the details of the process, we press another button. The details are in the form of an IBM assembler language text. We may scroll the text past the viewing area to position it at some interesting point. These 3 lines are apparently misplaced, so we may remove them and reinsert them correctly. The string RCENTR is incorrect. We erase the R and then the blank. The text is automatically readjusted. The word should be centroid, so we indicate an insertion caret and print OID on the dotted line. Erasing the caret causes the OID to be inserted between the R and the parenthesis. Below, the characters comma R4 are no longer needed, so we erase them and also the resulting blanks. We may then decide to insert a blank line between two existing lines and add some text. In this case, the expression add to R11 the contents of the cell BASE, base. We also decide that the string RCENTR should be FORMAT. There is no need to erase the incorrect characters. We simply print over them and erase the remainder. The last editing task is to erase the line SR, R12, R12. Then by erasing the blank line, we cause the text to close up. The scroll may be returned to its original position, and we may ask for a data abstract. The data display may also be scrolled for positioning. The vertical lines of checks on the left denote various data types, while the area to the right is used for data definition. To return to the coding scroll, we press the Return button. To move back to the diagram, we press Return again, which takes us to a list of uses of this routine. Pressing the check causes the correct display to appear. By pressing on another box, we find its interface display. Which is quite simple. We list takes us back to the topmost level, where we may start to edit the flow diagram. First we erase flow arrow, then move the connector out of the way so that we may draw a box in its place. The printing in the box is being used as commentary only in this case. The box is slightly too large, so we may change its size. Then draw a flow from the connector to the box. Attach a decision element to the box and draw a flow from it to scan. We then erase the flow arrows attached to the process post new area and move the box to a new position. This allows us to draw a new box. Then chop off the corner and label it subscan with a residual error. Draw a flow from post to subscan, correct the label, add a decision on subscan so that controlled flow to the connector A0, then complete the diagram from scan to post. We then leave this graph file and return to the graph file control page. The next sequence illustrates the construction and simulation of a flow diagram. The problem is simply to generate random integers between 0 and 7 and watch their effect on the flow of control. First, we draw a box. Connect it to the control source and then press on it. This process was not predefined, and we have the option of choosing more flowcharts or coding forms or a library search. We will choose the coding form. The purpose of this process is to pre-assign some values for the random integer generator. The instructions are printed in place much as one would on a standard form. As we proceed from line to line, each line is checked for possible error, and any data references are extracted for future use. Note on this last line the sequence exit n parenthesis minus parenthesis. Again, we press the upper left corner to return to the diagram. Notice the minus sign. Then we draw another box in an arbitrary area, connect it to the previous one, and mark the minus sign. This process is to be labeled RANDOM, random. It is the process that will draw the pseudo-random integers. Because the process has been predefined in this file, when we press on it, the translation display appears to be filled in. In this case, the translation is quite simple and requires just 2 parameters. To return to the diagram, we press return, then draw a decision element on random, label it, draw a remote connector, and modify it to represent a switch. Control flows from random to the switch. Label the switch with a name and a variable subscript. To provide a terminal for each value of the subscript, we draw 8 remote connectors and label each with the same name as the control switch and subscript each with a numeric value from 0 to 7. To simplify the problem, we draw another remote connector and label it, then gather all of the control paths into it. Note that this connector has no control flowing from it. To close the loop, we draw another remote connector, give it the same label as the collection point, and draw an arrow from it to random. Before we can simulate the process, we must assign space and values to data variables. When we printed the switch subscript, or entered a label on the interface display, or used data labels on the coding form, each was stored away to be presented on this display for precise definition. After completing the data definitions, we return to the diagram and ask for the simulation mode. The new display at the top is a variable speed indicator. Control flows through the preconditioning code to draw an integer and on through the switch to a connector, to the collection point, and back to repeat the cycle. We may then stop simulation, ask for a new set of control buttons, return to the construction mode, and finally return to the system file editor. At this point, both of the graphic files we have worked with have been stored on verification and checking.